Everyone, welcome back to Manufacturing Hub. This month, the month of March, we're talking all about ERP, Enterprise Resource Planning. We've got Glenn on this week. We'll introduce him in just a minute. And this is the conclusion of our ERP episode. So if you guys want to know more about ERP, we will have them. We've done a little bit different numbering this time because we've got so many fun things coming out. It's every other episode starting from episode 199. So episode 199, episode 201, 203, and this episode 204, because we like to go make things slightly interesting, as I just said. We do want to thank the folks at Talon for sponsoring this. And if you guys want to learn more about Talon and the work that they do on the ERP side, please go check out episode 199 with Elvis. Having said that, if you guys are new here, welcome. If you've been here before, welcome back. If you guys are new here or you haven't been super chatty in the chats, ours is a live show. We like to go have fun. We like to go bring your questions and comments and everything else in to our conversations. I think Dylan is probably going to be in the chat at some point. Absolutely go ahead and try to stump Glenn. Those are always my most favorite comments.
Please do.
Yes. So go ahead and try to stump Glenn, or if you've got questions for Vlad or myself, please go ahead. Feel free to ask those questions. Happy to go ahead and bring them into this conversation. But without further ado, everyone, again, officially welcome to Manufacturing Hub. This is episode 104. We are talking all about ERP this month long, this week being the last week. We'd like to introduce our guest this week. Glenn, welcome to Manufacturing Hub. Thank you so much for being here.
Hey, thank you, Dave, and thank you, Vlad. Pleasure to be here. And nothing gets the juices flowing like an ERP discussion. So how could I miss this?
Absolutely. I would definitely agree with that statement. I think the conversations we've had thus far were very interesting and I want to say insightful for me, but I'm looking forward to the conversation with you, Glenn, today. But before we dive into the ERP landscape and sort of break it down even more for our listeners, could you give us a little bit a backstory, your background? How did you get into manufacturing, your career, and ultimately what you are doing today?
Yeah, I'd be happy to. So the short version of the story is I'm an engineer with an MBA. So formal education in mechanical engineering. And I spent the first decade of my career in a variety of plant engineering roles. And so in some of them, I was multiple years stationed at the same plant. In other ones, I was working for GE and being kind of flown around the world. And each week is a new plant and a new diagnostic test to implement. And I was able to do all sorts of fun things like RCM analyses, building reliability programs, lots and lots of predictive maintenance work, and lots of root causes, more than I can remember almost. So I had a great first decade of the career. Just every day was a new day on the plant floor and really enjoyed that. After that, I like to joke that I went to the dark side and got my MBA. And so for the 15 years ago since then, I've been working in a variety of business roles. And the dark side is a joke. In truth, all of the business roles that I've had are every bit as engaging as the engineering roles, and I love them, and I would never inhibit an engineer from going to this particular dark side and learning some business. So yeah, in that world, I did a lot of product management. That was probably by time the biggest thing that I did, and a lot of mergers and acquisitions. And a shout out to both of those positions. They're fantastic for learning if you really want to broaden your horizons as an engineer or a technician. Working in either of those roles, product management or M&A, is just really great. And so to wrap it all up, eventually I became the president of a laser manufacturing firm here in the greater Seattle area. That firm is called Synrad, and we make high-end industrial lasers. And right now I am the chief product officer at an industrial internet company called Weights. So we are focused on condition monitoring. We are an industrial IoT platform, and we do all sorts of amazing things with vibration diagnostics and lots of other diagnostics, combination of machine learning, sensors, networks, actual human analysis. And so it's got a little bit of everything. I really love it there. Mm-hmm. And I'm happy to announce, you referenced Dylan earlier. Next quarter, I'll be launching a boutique firm with my business partner, Dylan Dufresne, looking at digital transformations for anyone in the manufacturing space. And I think you guys know Dylan really well, right? He's more famous than I am, to be honest.
We don't know yet who's going to be the face of the company, but we'll save that decision for the two of you, Glenn. I have a ton of questions for you. I think you have a very interesting background, and I can certainly resonate with going to the dark side a little bit. But I do want to ask you, maybe on that career path, and speaking of the dark side, right? What led you maybe to that decision, and how has it, for those who are maybe looking into an MBA program or any, to be honest with you, engineering management maybe degree, how has that
Yeah.
benefited your career and knowledge maybe since then?
Yeah, so for what led me into it, I'd like to say the good thing was just good old fashioned intellectual curiosity. Like most engineers, they love to learn new things. They stagnate if they're doing the same thing day after day. And so the biggest driver was just I was really curious about economics. I wanted to understand how finance worked. And so that was what really drove me to do that. But the other thing was on the slightly negative side, most younger engineers, myself no exception, things happen in a company and you're like, why on earth did we make that decision? Like, who are management simply unintelligent people? Or like, what is playing out here? Why are we doing the things that we're doing? And invariably, I can assure you, I've looked back on that period. None of my management teams were unintelligent people. They were just using mental models that I had no exposure to and making some really wise decisions. And I'm super glad that they didn't listen to 22-year-old Glenn when he had these great ideas about what he was going to do. So those were kind of the carrot and the stick version of why I did it. I was just curious and I love learning and I couldn't avoid it. But also I was like, why are we making these decisions? I can't make sense of this world. I need a formal training in it. And of course, I was the uninformed one in retrospect.
Let me ask you a follow up on that.
Okay,
go ahead,
I was going to say.
Go ahead.
I guess let me ask you a question, Glenn, because
Yeah.
you are probably the 15th, 20th engineer that we've had on who engineered to MBA, right? And I think you probably have lived much more of that executive life than the vast majority of them. You're maybe slightly longer in the career than the majority of the other folks that we've had. Looking back, what would you say top takeaway or most valuable takeaways from going and getting your MBA post time as an engineer?
Nice. Can I call an audible and give you two? It's hard to limit it to one, but there's two important things there. So first of all, the mental models associated with the core MBA topics. So financial accounting, marketing, human resources, leadership and development. There's like a core 5 courses that you take. By far, the most valuable thing was understanding the mental models that are associated with each of those disciplines. They weren't intuitive to me until after the fact, and I just didn't know them. They're not the sorts of things that would occur to you if you're sitting on the plant floor contemplating. And so for sure, your eyes will open when you understand each of these different ways of thinking. So marketing is fundamentally a way of thinking about all of the activities that are going on and how you add value. As is finance. Finance is a way of quantifying the type of value that you add. Strategy is a way of bringing the two of those together and saying, in what scenarios am I plausibly going to add value? And in what scenarios do I have no hope based on business fundamentals? And that's a really bad idea that we should reject and not touch. So number one, you don't know what you don't know until you take those courses. And we engineers, unfortunately, it's pretty common that we didn't even take intro to accounting in undergrad because there's so many courses you have to get through. So like our schedule is packed. After junior year, we cease to be real functioning human beings. All we do is technical stuff every day, all day. And so we just never take economics, business, et cetera. And so that's number one. And number two is really less about the MBA and more about getting into management. A classic failure mode for engineers is that they think that the world should operate rationally according to their definition of rationality. And they really believe that in their hearts. I did also as a younger man. And that's just not how the world operates. There are levels upon levels of different motivations depending upon who you are, what lens you're looking through the world, whether you're 10 years away from retirement and just really need to ride it out, or you're an aggressive younger person that just wants to take on as much responsibility as possible, or anything in between. Everybody has a different lens through which they're viewing the chessboard in front of them that is their job. And until you really understand those different lenses and realize that communicating within other folks' lenses is really the only plausible way to influence somebody. You can still run around, even with perfection of the MBA models, and just not get anything done and find yourself just irritating people left and right and all over the place. And so that's perhaps a longer answer than you bargained for, but I recommend any engineer to do those two things. Please study the canon of the mental models associated with the core MBA topics. And after you've mastered that, or while you're mastering that, understand the many, many motivations of human beings and the lenses through which they see the world, and never discount how important that side is when your goal is just to get something done with a bunch of people.
I really like that breakdown, to be honest with you, Glenn. I think, I'm still only a couple of years after the MBA, and I think I'm still digesting a lot of those materials because, as you've said, until you apply it in the real world, I think book knowledge is one thing and the models are one thing, but human beings are often very different than what you can find in a case study, right? So it takes time. I think there's a lot to learn. For me, to be honest with you, and I don't know if this resonates, I went in looking to find a lot of answers, and if anything, I think I found more questions, right? So as I learn about those departments, now I have even more, you know what I mean? I have I don't want to say I have a lesser understanding, I have a greater understanding, but I have even more questions as to how certain things are done, more so than, you know what I mean, when I was just focused on the technical aspects. But in any case, I don't
Which
want
is
to
a great
dwell.
thing. Yeah.
Yes, I don't want
I think
to.
that's a wonderful thing, Vlad. Yeah.
Yes. Let me ask you, speaking, of your career experience and maybe
Yeah.
transitioning us back to the conversation on ERPs, right? So ERPs, in a very broad sense, touch a lot of the departments that you just mentioned and a lot of those disciplines, not on just the technical side, but you did have an experience as an engineer early in your career with ERP systems. So maybe could you
Yeah.
tell us a little bit of that story?
Yeah, absolutely. So, actually, an open secret. Many engineers, when they first graduate from school, don't actually know anything about how an actual plant floor operates. And so I was no exception. I knew maybe 1% of what I needed to know on the plant floor. And so my first job was at a nuclear plant. So I go to the nuclear plant, and being an engineer and having spent infinite all-nighters working on calculus, you would think that people are running around like, oh my God, Glenn, we need the integral of 1 over cosine squared to the power of x on the interval 0 to pi stat. And of course that doesn't happen. That's just not a thing. I was very overwhelmed, as are many young engineers. Please be kind to them if they're on your plant floor too. And right out of the gate, it was clear to me that there were two systems that I had to master because they were just pervasive. One is what we're here to talk about today, which is the ERP. And the other one is the design basis of the plant, and specifically the P&ID. And Vlad and Dave, let me know, should I assume listeners are steeped in P&IDs and I don't have to define what they are?
I guess I think I would prefer to hear a definition, right? Because I've personally been in a very discrete manufacturing process, and so P&IDs were not necessarily, the topic of conversation early in my career. So I
Mhm.
wouldn't assume that everybody knows them well, depending
Okay,
on the
super,
vertical.
yeah.
Mhm.
That
Yeah,
sounds great. Yeah. And they do tend to be more central in the process industries. For sure,
correct,
they're more
correct.
central in process.
Yep.
But anyway, it simply stands for process and instrumentation diagram. And what it is a very compact schematic language that lets you describe any given system. And
Mhm.
so they have information, they have symbols that stand for valves and air operated valves and motor operated valves and pumps and compressors and motors and controllers and transmitters. And so it's a very symbolic language, which once you learn it, is a really compact and a really elegant way to describe what's happening on the plant floor in any particular system. And so if you looked at it right now for the first time, it would look like a spaghetti diagram of foreign symbols. Once you ramp up, it actually becomes very comfortable, and you're like, wow, this is a great language through which to express ideas about how a system is working. And so if we zoom back to young me, first week on the job, I'm steeped in P&IDs and the ERP system, and it's clear that I'm going to have to use both every day, all day. On the P&ID front, as the weeks planned out, the more I looked at P&IDs and the more I compared them to the actual systems I was troubleshooting on the plant floor, there was this virtuous cycle of learning. First of all, the PNID, it looks crazy in the beginning because you don't know all of the symbols. But over time, there's a finite number of symbols, and they really throw you a bone. Like TT217 means temperature transmitter 217. Like they're at least throwing you a bone and trying to make it intelligible, which I really appreciated. Like TIC is a temperature indicating controller. Thank you for making the standard intelligible. So anyway, you learn that language, and when you eventually, as you're becoming more and more comfortable, believe it or not, it's like enjoyable to read. It's like reading a textbook. You look at the system and you start to make these observations just by staring at the PNIDs. Like a big one that I had was like, what the heck? Almost every single control loop is a single input, single output PID loop. Like that's chapter 2 of the controls textbook that you agonized over in school. But then your professor made you have 50 all-nighters after that with all kinds of other stuff. And what do you know? 90% of the loops on the plant floor are just simple single input, single output PID loops. And I was like, I could have saved a lot of time had I known that in advance. I digress. The point is, very quickly, PNIDs become fun. You understand them. There's this virtuous cycle of learning, and they're very intuitive. And I never took a single like training course on how to read a PNID, nor did any of my peers. Now let's talk about ERPs, the other big system that I had to learn. It's as close to the opposite of that as you could ever imagine. So in a minute, we'll get into what our ERPs do specifically, but here I just want to highlight that you bring up an ERP screen, and what you see is field upon field upon field that bears no resemblance to the plant floor that at the end of the day, you're doing something about. If you're here, you've done some kind of work on the plant floor that you would like to express in the ERP. And yet all you see is blank fields and some fields filled in with codes that make no sense to you, that do not match, like TIC is temperature indicating controller. Not the case in the ERP. There's all sorts of shorthand notation that means nothing to you. And long story short, you sit there like staring at a blank screen, trying to figure out how to express your intentions and document what you've done. And it's ridiculously hard. So you actually go through weeks of training on the ERP system and training upon training. And even after that, everybody's like, my understanding is so brittle. I still don't even get why this system exists. I don't understand what I'm doing when I do it. All I've done is memorized this insanely brittle path through the system to do exactly what I want to do and only what I want to do. And if they ever changed anything, I'm screwed. I have no idea what's happening. And so that was my initial frustration with ERPs. On the whole, it was the hardest imaginable interface to like figure out what the heck you were even doing. And I found that frustrating early in the career.
I'm curious, I guess, really briefly, Glenn, in that context, what was your intention with the ERP systems? Was it getting some kind of data to make decisions, or what were you using it for at that time?
I would describe it as enterprise asset management. So the real quick story, inside of that ERP, we had an asset hierarchy that reasonably reflected what you would see out on the plant floor. And then we would issue work orders, whether they be corrective work orders, predictive maintenance work orders, preventive maintenance work orders. We would issue those directly inside of the ERP. Most people would call that a CMMS. In this particular case, we were implementing CMMS functionality directly inside of the ERP. But yeah, the vast majority of tasks outside of like HR timesheet stuff was what you would find in a typical CMMS. Enterprise asset management, work orders, asset trees, asset information, the ability to procure like a new bearing for a particular one that failed and things like that.
Gotcha. Dave, what are your thoughts?
Absolutely, Glenn. I feel like you have you've hit the nail on our head. Hit the nail on the head for the majority of folks' thoughts early on, or maybe end of career, in regards to ERPs. I'm sure that we could talk about kind of those early thoughts for a long time, but you have progressed substantially from that point in your use of ERPs. Maybe not necessarily your understanding of ERPs, and why we've made the decisions in the past the ways that we have. But when we were talking about this, you said that there are a few kind of key items when we talk about ERP fundamentals for beginners. And so if someone is new to legacy ERP systems, or perhaps someone is frustrated in the ERP solutions that they're currently using, can you walk us through what you're defining as some of these fundamentals, please?
I'd be thrilled to. And yeah, the good news is I've come to peace with ERPs. Like I've used them 20 however many years now. I finally have mental models built up in my head to understand what they're doing, why they exist. And I would love to share those with all your listeners to see if it's helpful for them. And these aren't in any textbook anywhere. They're just honestly the things that I built up through real life experience. And with any luck, they're helpful, and let's roll.
Mhm.
Cool. Okay, so let's start with mental model number one, a very simple one. It's helpful if you think of ERPs and any given module within an ERP as having three different things coming together. Those three things are master data, number one, transactions, number two, and a workflow, number three. I'll give a brief description. I'll repeat that and give a brief description about what each of those are. And then know that what I'm going to do subsequently is kind of go module by module with more specific details about each of those things. So let's start with the first one, which was master data. Master data is very similar to configuration data. And it's data that you enter into the ERP and that stays relatively static over time. So some classical examples of these are the asset hierarchy. If you're using a CMMS within an ERP, that's a relatively, not completely static, but a relatively static thing. If you're in a product manufacturing oriented scenario, the bill of materials. The bill of materials for a product is reasonably static, absent changes to improve reliability or something like that. And the vendor master, let's say you have an approved vendor list inside of your ERP for procuring parts from whoever your supplier is. The vendor master for any given supplier is a relatively static document that you configure once and only make changes when exceptional things happen. And so all of these are simple examples of the first thing, which is ERPs are a holding place for important data that I'll call master data that does not change quickly over time, relatively static. Number two was transactions. So an ERP is also the place that records all sorts of business transactions that aren't recorded in any other way. When we talk finances in a few minutes, I'll get very specific about what these transactions are. But for right now, for your mental model, just think that transactions can be almost literally any action that you take in business. So you issue a purchase order, transaction. You receive a quote and approve it, transaction. You move a thing from a storage location and inventory to the floor so it's ready to be built, transaction. As you just go about your normal daily job at a plant, you're having everything that you do is a transaction of some sort that can and should be recorded inside of the ERP. And so this second layer is the transactional layer. And you tend to generate those unbeknownst to you. So it's never your mental, the chatter in your head is never like, I am creating a transaction. Here is another transaction. You're just doing your thing. You're just doing whatever your job is. And in so doing, you're clicking buttons in the ERP and creating back-end transactions that we'll get into a little bit later. And then, yeah, the third thing is a workflow. The workflow I use in the broadest sense of the term. The workflow is simply like there is a thing you're trying to get done. You don't put data into an ERP just for fun. There is a desired end state that you're hoping to achieve. And so the classic one in finance is the desired end state is you want to make the three big financial accounting statements. You want to make an income statement, a balance sheet, and a cash flow statement. And so here I use the word workflow broadly to mean whatever the desired end goal is. And that'll change module by module. So yeah, to forgive me for repeating myself, but this really helped me to absorb what was happening in an ERP, just to say three things: master data, transactions, workflow. If you can understand those three facets of whatever module you're in, you're on the right track.
I really like that. To be honest with you, I think that's a really solid breakdown. And yes, I obviously have a lot of different thoughts and kind of like conversation points onto the different departments. But I think in a general sense, that makes a lot of sense the way you've broken it down. So really appreciate that, Glenn. Dave, thoughts,
Yeah,
comments?
Glenn, but before we step into the first kind of major module,
Yeah.
did you come up with this model? Did you learn it from somewhere? I haven't seen it described quite this
Yeah.
way, and so would love to know how you came up or came across this.
Yeah, to be honest, it's my own mental model. Master data is not my own term. That's a very
Yes.
standard term. And in fact, I'm using it a little bit too broadly here. If you were to pick up a textbook on ERP and look up the definition of master data, it would be a narrower definition than what I just stated right now. But no, maybe I should urge caution to the users that this is Glenn's model. Like if you walk around citing these three things, people might not know what the heck you're talking about. All I'll claim is, boy, did it help me when I started thinking in those three tiers, and I hope that it's helpful to anyone else.
Good. Yeah,
Absolutely.
absolutely.
100%. Go ahead, Vlad.
I was gonna say, and maybe to discuss the modules, right? I think to get into a little bit more granularity, starting with financials, right? So financials, you've mentioned, obviously want to create the three sheets that you've mentioned, but what does that truly look like? Because again, a lot of that information is coming externally. A lot of that information can be coming from vendors, suppliers, right? Could you maybe explain to someone
Yeah.
who's not experienced that, what does that truly take?
Absolutely, will do. And so the big picture here is the discipline is financial accounting. So if you're, I actually thought maybe I should literally try a financial accounting tutorial live in a 10-minute window on the. I think that's a little bit too ambitious. But what I do want to say is literally financial accounting 101, like the one that everybody takes in college, unless you're an engineer because you don't have time. That is the discipline that underlies the financial module. And so everything I'm going to say here is just right out of the book, financial accounting 101. And so if you really want to learn this in depth, all you got to do is pick up that 101 textbook and it'll explain everything. But because I'm incapable of thinking without kind of like putting everything into atomic chunks, I'll describe how I think about financial accounting and we'll roll from there.
Let's do it.
So first of all, this is probably the biggest reason that you're having a bad experience inside of your ERP. ERP, first and foremost, has to get the financial accounting piece right. And the consequences are enormous, like literally people going to jail, investors being defrauded because they interpreted your financial statements to mean something different than what is actually happening. And so this is a must-have for legal reasons, for ethical reasons, for everything. The ERP absolutely has to nail the financial accounting piece, and it tends to do that. And so anywhere downstream of the financial accounting piece, if there's a trade-off to be made between the user experience and the functionality and what feels intuitive versus what you know will absolutely get the financial accounting right, you always err on the side of getting the financial accounting right. And in one simple statement, that's why you'll have an inconvenient user experience in a whole lot of the other modules. So let's start with financial accounting. A sidebar question, Dave and Vlad, do either of you have a favorite like equation or technical topic? I promise I'm going somewhere with this. Do either of you have a favorite equation? I'll ask you right off the cuff.
Sure. I mean, I can start. I always in my head convert everything into V equals IR, right? Because you'll learn in electrical engineering, at least I don't know if you learn that on the mechanical side, but any model or any system, the heating in your house, your process floor, even your financials can be modeled as a control system from an electrical engineering standpoint. So I always think of, I guess, V equals IR as the first go-to as an equation.
I love that.
I love that too. I'm terrified of where this is going. So we'll just go with Vlad's answer, and then that way I'm not going to catch what. Yes.
No worries, and I'll share it too. I'm very unoriginal, but my favorite is the Fourier transform because it's just so pervasive in my world of vibration. But the reason I asked that question is most engineers have this experience where they look at their favorite equation or their favorite technical area, and there's something more than just the math there. They tend to use the word elegant as like the highest compliment that you can give to an equation. And so for me personally, I think the Fourier transform is extremely elegant. It's an amazing compaction of information into a very tight space. And it's so creative and so unintuitive. I would never think of it in 100 years if I was sitting in a room and in a strange situation where somebody was like, you must do math for 100 straight years. I would never think of it. It just wouldn't happen. So I feel that same way about the fundamentals of financial accounting. When I studied it for the first time, once I got over the hump of learning what it was trying to do and it finally felt natural, I was like, this is an extremely elegant system that any technical person would really appreciate the beauty and the simplicity of it after they get over the learning hump. And so my main goal in sharing that is motivational. That know that there's this guy named Glenn that went over the hump and was like, this is as elegant as Maxwell's equations or the Fourier transforms, and like, this is really cool. That wasn't the opening speech that I got from the accounting professor when I took the class for the first time, and I wish I had. I wish he said something like that when we started. But so I promise you, elegance awaits once you get over the hump. So now, in lieu of describing literally the whole system, let me give you the bare minimum of important pieces as relates to the ERP. So within financial accounting, it turns out that everything comes down to what's called dual entry bookkeeping and the recording of transactions. And so there is one single equation at the heart of all of it, and that is A equals L plus OE. Assets equal liabilities plus owner's equity. Don't worry about what those are for the moment. What I want to express is, in this system, every time you do anything financially, it turns out that you have to debit something, some account, and you have to credit some other account. In this context, debit and credit are mathematical operations. They're not that complex, but don't worry about what they are. They're a thing. And anytime a transaction happens, you have to equalize the debits and the credits. And anytime you do anything like changing inventory, buying a thing, paying an accounts payable, every one of those behind the scenes, whether you know it or not, you are debiting some account and crediting some account. And that is the transaction that I was referring to in the big three things. So I won't go further than that, other than to encourage everyone to read up on financial accounting. It's cool once you get the hang of it. Debits and credits rock. You're going to love it. And for ERPs, though, you'll just have to take my word for it that every time you do a financial thing, there's a debit and a credit, and that constitutes a single transaction. And that is the most important transaction type inside of all of the ERPs. But now let's go back to the original. Vlad, please go ahead if you had a question.
I was gonna say, for me, to be honest with you, Glenn, what was really interesting, and I guess what I didn't know in hindsight, right? I think the engineering mind, to give you an example, and I think this will also tie in a little bit into the Lean Six Sigma conversation we'll have a bit later. But ultimately, as an engineer, you always think we want to produce as much product as possible. We put it in the warehouse, everything's going to be great, everything's going to be sold. But the financials, depending on the snapshot or the time frame you're looking at as well, will tell you a story of how your operations are performing. And so for me, once I learned accounting, that unlocked quite a bit, because now you can look at those sheets and again, you can understand what's happening on the technical side from like a time basis, right? And so you can see what's your inventory turnover, how much you're holding, how much that costs. Because again, as an engineer, you think that the technical component is the most important, but in reality, there's a lot more at stake and at play than meets the eye. So for me, once you unlock that accounting piece, you can actually understand a lot of those components as well.
Well stated. Yeah. It's a different language, and there is so much rich information encoded in there. Almost everybody who makes it through managerial ranks has this humbling experience where they're working on a mergers and acquisition deal, and there's like a 23-year-old kid out of school with 2 decades less experience than you, but they've mastered financial accounting, and they look at the financials and they have these insights like instantaneously that you're like, what is he? He can't possibly know that. And then you go through the exercise, like, I'll be darned, a 23-year-old just like showed me up. And like, everybody has had some humbling experience like that, which shows the power of what you're talking about, Vlad, that man, with just those 3 financial statements, you'd be amazed how much insight you can gain about the fundamentals of the business. So I'm with you, brother.
Absolutely. Yep.
Cool.
And so I guess just to close that off, right? So we create those 3 ultimately financial statements for mostly tax purposes, right? But we can understand by viewing some of the financial data, the state of manufacturing. Maybe could you kind of wrap it as to how that financial data, comes into play in the ERP systems at the end of the day?
Absolutely, yeah. And I'll add just one quick thing, if you don't mind, Vlad, and then I'll answer that question. But taking it back to this master data, transactions, and workflows, Just to be abundantly clear, in this core financial accounting module, which is the most important, it's the 800-pound gorilla in any ERP, the master data is primarily the chart of accounts. So there's a chart of accounts that cover revenue and expenses and cost centers and all of that. That's the most important master data that's relevant here. The transactions, as I said, everything you do will debit and credit some account on the master chart of accounts. And then the workflow at the end of the day is all about generating those big three financial statements. And so thank you for giving me just a moment to tie that back to the big three model. And then, yeah, your question was a great one. Like, okay, if these financial statements are packed with so many insights, like let's have some. How can we do that? So I'll just give you a select few that I think are helpful. If you start with, let's look at the income statement. Obviously, revenue and revenue growth is important. That's sort of a superficial insight. All else equal, of course, you want more sales and you want more growth. And yeah, you guys could have told me that. That's not it. You don't need a podcast guest to go through that. The next line down actually hides a lot of really, really important stuff. So the gross margin. Gross margin happens to be my single favorite individual metric. Inside of the gross margin, there's only a finite number of ways you can improve the gross margin, and it's a really hard metric to cheat. So specifically, gross margin is simply the product that you sell, the revenue, less the cost of goods sold, the cost that you had to put in to make that thing. The higher your gross margin, it's almost always correlated with a bigger moat in the market. And then that moat could be any number of things. Here, I mean moat in the sense of a castle with a moat around it. It's a commonly used term in business. You want to have a moat in your business, which means it's really hard for other people to get in. The higher your gross margin, almost always it's the case that you have a really substantive moat that's a protection against anyone that's competing with you. The generic types of protection you might have is, let's say your engineers came up with an amazing technology that functionally outperforms the other guys on whatever parameter is most important. So like my background is in laser and metrology, and so we were always worried about accuracy and power stability. But in whatever category you're talking about, if you genuinely build the quote unquote better mousetrap with better functional performance, then you can command a higher price in the market and your gross margin goes up compared to your competitors. So that's one way that you can increase gross margin. Another way is you can be a better operator. So you could be able to make functionally the same exact performing product, but you do it much more efficiently because of some secret sauce within your process. And so whether that comes from just higher volumes and that pushes your cost down overall, or if it comes from a really clever process engineer that figures out a way to get this thing manufactured at scale at reasonably low cost, like that's a real moat. And then in this case, what you're doing is you're charging the same thing as your competitors, but it costs you much less because of that process wisdom. And so that's another great way to improve your gross margin. But in either case, as soon as you see any company that has a gross margin that is notably higher than other nominal peers in the industry, that company is doing something genuinely differentiated, and you want to figure out what that is. It's worth your looking into. And I'll close by saying, it's really hard to cheat gross margins. It's not hard to cheat operating margins. So in gross margins, all that you know is the difference between the revenue you sold and the fundamental cost of goods sold. Revenue minus COGS, gross margin. So you can't cheat it. The only way you can do better is have a better product so you can charge more, or make it more efficiently so that your costs are less. Like there's no other way to cheat against your competitors. As contrasted with your net profit margin or your operating profit margin, those take into account discretionary expenses. Like you have to pay for an executive who sits in an ivory tower and gives commands to everybody. You have to pay for a marketing team, for an R&D team. So sales and marketing, R&D, general and administrative were the big three categories. All of those, you can increase your operating margin, which would make it seem like your company is doing better and better, when all you've really done in the background is, shoot, let's just slash marketing costs and our operating margin will go up. Mm-hmm. There's no equivalent way to cheat a gross margin, and that's why it's one of my favorite margins out there. You have to earn your way to a high gross margin. You don't have to earn your way to a high operating margin. You can do that, at least for a while, by slashing and burning every possible cost. That doesn't end well, typically.
I want to, I guess, add really quick an asterisk right, Glenn? Because I would not want to assume that a lot of our listeners know accounting to a deep level. So when you say cheat, it doesn't mean to necessarily commit fraud. It means that you can manipulate
Thank you.
where you allocate. You know what I mean? I just want to make sure we're on the same page here, right? Because ultimately, again, like looking back at my experience as an engineer, like again, you think that accounting is a much stricter practice, and in reality, some of it is, I want to say, art more than it is science, right? You can
Yeah.
put different budgets into different buckets. So again, like when you say cheat, it doesn't mean commit fraud. It means that you're essentially allocating and manipulating numbers to some extent within the confines, but you're painting a different picture on those sheets so that it might represent the company in a different way.
You
Good.
got it. You understood my intent perfectly, and I'm really
Good.
glad you
Excellent.
specified. I did not mean literally committing
Yes.
fraud.
Yes.
Everything
Well,
assumed you're following the rules. Thank you, Vlad. Yeah.
And I would say if you are going to attempt to commit fraud, you probably don't have a very strong ERP system, because that would almost certainly make it significantly more difficult to go through the process of committing fraud on your balance sheet and
Yep.
on all of your reporting in there.
Yeah.
Glenn, that was awesome. I do want to make sure we get to the other
Okay.
sections
Well.
of ERP. Although some of us could have accounting 101 traumatic flashbacks for the next 45 minutes. And that would also be a lot of fun. I have not thought of those classes in many years. So thank
I'm
you
so
so much for
sorry,
that, Glenn. No,
man.
it's okay. It is okay. We want to talk about supply chain, right? So we've built
Excellent. Yeah.
everything along the lines of everything is a financial model, right? So a business organization, everything is a financial model. Because everything is a financial model, your ERP is a financial model, and it's going to make many of the other things that we try to do slightly more difficult, because it all has to fit within the financial model that is as rigid and inflexible as anything that a human could probably create. So from that, we're going to build the supply chain on top of it.
Super. So let's go supply chain. So I'll introduce another mental model here that this one I did not make up. This was taught to me by two really great operators named Joel and Jeff, Joel Hartel and Jeff Fowler. I hope they don't mind me saying their names live on air, but really smart guys. They taught me much of what I'm about to describe to everybody here. But yeah, so within supply chain, it's very helpful to, first of all, identify a spectrum from push to pull that identifies what your overall manufacturing strategy is. And so to be very explicit, lean manufacturing can be thought of as fundamentally one end of the spectrum and is at its heart a customer pull methodology. And by that, I mean that the signal that goes upstream to everybody that lets them know what to do originates when a customer issues a purchase order, purchases a good, and then pulls it out of the finished good inventory. So it's helpful to literally, in your mind, picture a customer with a rope around a thing, pulling it out of the factory. Lean is a customer pull-based model. And what's amazing is if you set up single piece flow and all the other things that you associate with lean, like carefully sized Kanban bins and things like that, if all of that is set up properly, which is not easy, and I give due respect to how hard that is to do, if you set that up well, then the signals that go upstream happen naturally in the course of doing the thing that you're doing anyway. So you pull a product out, the final test person now knows that they need to fill that and do another thing. And the system very naturally cascades upstream. And there's people walking around the plant. And if you used up a Kanban bin, they know they need to refill that one. And that sends a signal to the supplier. And the beauty of that end of the spectrum is very little forward planning is required. So to the extent that you have high flow, low mix, really good single piece flow with no batch interruptions in between, you can be really successful on the lean model. The reality is it's much more common for people to be closer to the other end of the spectrum, which I'll call the MRP model. MRP is manufacturing resource planning. It's a many decade old discipline. It started with Orlicki, I believe, in the 60s or 70s. And actually has a really rich history you can study sometime. But the basic idea behind it is super straightforward. The MRP model is fundamentally a manufacturer push model. And by that, I mean the manufacturer puts together, let's say, a 6-month forward-looking forecast of what they intend to manufacture. And more specifically, it's always a combination of your backlog, which is customers that have already given you purchase orders. We call that the backlog. You know that customers want that. And then at some point, your backlog goes to zero and you have to forecast what is my anticipated customer demand. But either way, what we're talking about is, hey, here it is. For the next 6 months, these are the exact SKUs that we intend to create in the exact weeks that we intend to create them. And then you take that metaphorical Excel spreadsheet and you push it. You push it upstream to everybody that needs to know. The factory floor supervisors that need to make sure that you have the right machines available, the right people on staff, the suppliers who make sure that they need to get their goods to you on time according to this schedule. And so more specifically, you go through a buyer. But either way, the message gets to the suppliers through the buyer in your internal team. And now everybody's operating to this spreadsheet. But it's very different from the other world because everybody's being pushed according to this forecast. I'll ask one wild question. How accurate do you guys assume those forecasts tend to be?
Not very.
Yeah, I'd say 10% would be really good. I don't know, 2.5%, 3% overall.
Yeah, it's a little bit better than that, but I love your pessimism in this scenario because it helps make my point. It's very hard. It's very hard to forecast the future. Incidentally, 70% is the best I've ever seen on forecast accuracy. That's like world
Really good.
class. Very rare, very rare. If you get up to 50%, consider yourself doing amazing. And it's just fundamentally hard to forecast the future. And so that's the Achilles. Or go ahead, Vlad, please.
Sorry, I was going to ask you, how rigid are these schedules, and I guess how forward in time are they looking, right? Because ultimately, I would assume it's on a 3 months to maybe 6 months long basis, but you would need to be adjusting on a rolling period as well, right? So you should be adjusting some of the forecasts. Like how does that actually play out or work?
So I'll give you the norms. I'm tempted to say it changes with every plant, which it does, but let me just give you the norms, the rules of thumb. So normally you refresh that entire thing once per month. And that entire spreadsheet is refreshed through a process called SIOP, which stands for Sales, Inventory, and Operations Planning. And this is a monthly process where the heads of each of those departments get together, share all of the latest information that they have, and then put that into one master schedule, which is this document that we're pushing to the supply chain. So on average, once a month is the refresh time. It tends to be a 6 to 12 month forward-looking forecast, depending upon the standard lead time of your product. And so all else equal, if you're making, for example, jet engines, those lead times are enormous. And so you go more than a 12-month view. But let's just say for the average manufactured technical product, 6 to 12 months is a very common forward-looking view.
Gotcha. Thank you.
And then you were also asking dynamics, like obviously you don't get it all right in that 1 month view. And so as you issue a thing on Jan 1, you issue this schedule, all kinds of things conspire to make that schedule completely wrong. And people call in sick, machines break down, suppliers don't deliver on time, yields unexpectedly plunge. Like the entire universe conspires to completely scuttle that 1 month plan. And so that's the Achilles heel of MRP. But obviously people are aware of this. And so what happens in practice is you never find anybody that's like 100% lean or 100% pure MRP. What you find is they do pragmatic things to try to like get rid of the Achilles heel of whichever methodology you're on. So on the lean situation, there's always some type of forecasting. It's super rare that like literally the only information with the entire system is an inbound purchase order from a customer. There's always some level of macro planning and debottlenecking using things like theory of constraint to like increase your capacity to make you more flexible in the face of demand. And so it's super rare that it's quite as clean as I described on the far end of the spectrum. And with MRP, what you would do is you need buffers. Basically, you need all kinds of intelligent buffers to account for all of the things that I said. And there's a myriad of ways that you can do that. They tend to be, if you ever hear about ABC or XYZ analysis, that's the most common one. And that's a variation on the theme of, listen, we've got all these parts. Let's at least break them down into some type of a grid that says how much do they cost individually and how many do we use per year. So like annual volumes or the flow and the cost of them. And then you can imagine if you get into a part that has super high usage and steady usage across the year and is also actually very low in cost, you don't want to take too much time like forecasting all of that because it doesn't matter. It's inexpensive. And so Fastenal as a company basically exists to serve that box. Those things tend to be things like base plates and fasteners and kind of commodity off the shelf goods. Most plants say, of all the item numbers that we need to like forecast and procure, can we at least skip the fasteners and just give that to Fastenal? They'll come around once a week, they'll fill the buckets up. It's really immaterial in the big picture of how much working capital we're chewing up. And so Fastenal has a fabulous business doing basically exactly that. And then on the other end, of course, it's tougher. It's tougher when you have a high cost, low flow item. You really got to be careful about forecasting that because you're really out of luck. Those tend to be things that are like sub-assemblies that are complex from a supplier. And if you sell like 5 instead of the 2 that you thought that you were going to, the supplier says, Glenn, geez, it takes us a month and a half to make every single one. It's a really big deal that you were off by that far. So yeah, in 3 months, maybe I can get you the next 3, but it's not going to be easy. And so that's the other end of that pyramid, if you will, or that 9 box. I fear I might have, forgive me if I've dived into too much detail. The real theme that I wanted to say is use your basic intuition to inject intelligent buffers, acknowledging that the schedule is always imperfect. And even if it were a perfect demand schedule that perfectly reflected the orders that would come in and what customers wanted, everything else goes wrong. Suppliers don't deliver, stuff breaks down, people call in sick. Like the world conspires forever to scuttle manufacturing plans. And because you know that, you do things like you would load a cell to 80%, not to 100%, knowing that sales is going to come in and they're going to say, oh my gosh, amazing order. I've got it in my hands. If you can fulfill by Tuesday. And the VP of Ops is like, son of, I can't, but all right, I can, but like, we kind of had a plan and this is not in it. And then, so you leave intelligent buffers to allow for inbound stuff like that. And then you also start to do intelligent design on the plant floor to make things as fungible as possible so that when demand doesn't come in as you expected on one SKU, you can take those, the people at least that were assigned to those and, move them over to build another product that turns out to have higher demand. And so basically that's the life of a supply chain professional. It's at least 10x, if not 100x harder than I appreciated before I dug into it. Like I thought, whatever, supply chain, you just buy stuff. All right, sounds good. Like put it in a warehouse, there's a slot. Like how hard can that be? Why do we have this huge team? And like, and then I got engaged in it and I was like, oh my goodness, this is literally impossible. Like, I don't know how anyone.
I love that. I love that. Supply chain, how hard can it be? You just buy stuff. Glenn, this is awesome. I definitely want to get into the manufacturing execution systems part, but first we have some folks that we need to thank. We want to thank Talon for sponsoring this month's theme and episodes, which are all focused on ERP platforms, trends, and implementation. Talon helps manufacturers navigate the tricky landscape of ERP adoption, migration, and integration work across SAP, Microsoft Dynamics, Oracle, and other platforms. Talon's mission is to provide active guidance through the entire process, from the initial consultation to post-deployment support. The combination of the right software and the right support can result in improved productivity, better data access and insights, cost savings through automation, and better overall manufacturing performance. You guys can go check out Elvis, who is Manufacturing Hub episode 199, which should be out on all the platforms now, or go to talon.com. That's TALAN.com. And again, we want to thank the folks at Talon for supporting Manufacturing Hub and sponsoring this theme. Having said that, Glenn, I want to go dive into manufacturing. Right? So we've set the stage on the financial side. We have made fun of all of the people who just buy stuff for a living. It definitely is a much more difficult job than we are giving them credit for here. Definitely thankless job, and they're always at fault when there are issues. So having said that, take us through the manufacturing side with the manufacturing execution system, please.
Excellent. So the number one challenge that I've seen on the manufacturing side, and first I'll pause and just give the basic idea of the data that you need in an ERP to do MES work inside of on a manufacturing floor. So here, when I talk about master data on the manufacturing floor, it tends to be called a work center master record. So in your ERP, if you look up or search for work center master, you'll see that, and the work center master tends to contain really important information about what a particular work cell can do, the capacities that it has. And sometimes it also includes routings. Routings are a related idea, except they're applied to a SKU and not to a work center. So, for example, you're making product X, the quote unquote routing describes how long product X needs to go through each of the various work centers along the plant floor until it finally comes out as a finished good at the back end. And so the master data that's most important in these cases tends to be the work center master and the routings information. Those constitute like the fundamental building blocks of putting a factory floor plan together. And then the workflow is relatively obvious in this case. It's as literal as it gets. You're building a product. That's your goal. You want to build this product. And so you need all of the information that's associated with what it takes to put everything together. So that part's relatively easy. And the transactions all relate to various stages of work in process. So transactions were the third thing that we use in our mental model of an ERP module. In this case, transactions are almost always motion of either raw inventory from the warehouse onto the factory floor, or various stages of development as you go through each of the work centers identified on the routing schedule. And you get, various stages of work in process until it finally culminates in a finished good at the end. Those are the transactions. And so it's usually a barcode scanner. If you're doing a light manufacturing and electronics area, there's typically like a barcode scanner that you scan to identify to the system that it's moved on to the next station. Those are the transactions. I'll pause for a second to let you ask any questions.
I was going to ask you, right, because ultimately in each one of these components, data and more importantly, contextualized data is extremely important, right? And so, I've certainly been part of very large organizations where I've seen a lot of automated components when it comes to MES or supply chain information. But maybe, Glenn, what are you seeing in terms of MES/ERP and data from maybe your customers or maybe your experience? How manual is this in the real world, right? And or maybe how easy it is to get some of that information to come into the system.
Yeah, what I would say is the folks that actually have an MES that they would describe as such, like an off-the-shelf MES separate from the ERP, that is super pharma heavy and semiconductor heavy and relatively rare outside of those. It's not non-existent, but I'd say it's relatively rare outside of those two verticals. So in the vast majority of cases, you're using the ERP as your MES system. And in that case, what you would call it is the work execution module. So in all likelihood, look in your ERP, there'll be a thing called a work execution module that is the quote unquote MES that you're using. So that's what I would say. Outside of the more regulated industries, it's less and less common. There is a line of complexity where it becomes really useful to have a dedicated MES. And so in the controls world, recipes is the classic one. So say you're working either in biopharma or specialty chemical, and there's a particular batch recipe that you need to implement. The management of that recipe and the associated controls that you need to load directly onto the PLC, that's much better done in a dedicated MES that was fit for purpose to do exactly that, and tends to be really kludgy if you're using only an ERP. But maybe for the purposes of this discussion, we'll assume that we're using the ERP, we're using what's called a WEM, a work execution module within the ERP, and that's doing what an MES would otherwise do.
Awesome. Thank you. Appreciate it.
Cool. Yeah, you bet. And so here it's easy. There is one central confusion that is the most common. Everything that I've described so far is relatively straightforward. And yes, of course, it's harder than it sounds to manufacture these products. But if your master data within the ERP tells you the parts that you need, the personnel and skill set that you need, the equipment that you need, and the routings all the way through them, I would never claim that's easy, but like you can put the puzzle together and calculate how you should lay out the optimal plan for your plant. The biggest difficulty, though, is what I like to call the supply chain factory floor chasm. I call it a chasm because it's the most common source of confusion. And it was for me until Joel and Jeff explained it, how it all worked, and then light bulbs started going off for me. So the basic idea is, back in the supply chain world that we talked about a moment ago, the governing document is the master schedule. And the master schedule is built up of purchase orders. So sort of the line item or the atomic unit is a customer purchase order about your SKUs that they want. When you move to the factory floor, the governing document, it looks similar. It's a big spreadsheet effectively, but it's called the master plan. And that master plan does not use the customer PO as an organizing principle. Instead, what it uses is a work order, an execution work order for the factory floor. And once somebody explained it to me, it seems so obvious in retrospect, but it just never occurred to me. Like if you go to the factory floor, you would think you could say, customer X, purchase order 2749, how's it going? Like, where are we at? Are we almost done? Is it going to be out by the end of today? And the factory would say, I have no idea. I'm implementing work order 247. I don't have a clue what purchase order that's associated with. All I know is I'm giving you 30 of this unit. At the end of the day, I don't know if it's for you, salesperson. I don't know if it's for somebody else, but I know for sure that's my metric and I'm going to hit it. And so that wasn't intuitive to me until people explained that difference, that in the supply chain, everything is according to customer purchase order, and supply chain knows exactly what you're asking. When you're a salesperson, you say, I need purchase order 247 to be implemented. The factory floor doesn't think that way, with the exception of rare cases. So one rare case is there are some plants, especially like specialty job shops, where there is no difference between the purchase order and the work order on the factory floor. And we call those make to order. So anybody that's in a make to order format, an order comes in, it contains complex work instructions, and then the factory goes and makes it on a series of CNCs or whatever it might be. I would say that's relatively rare. For larger factories, it's less common. Much more common is you're making to forecast, i.e. building to the forecast that's embedded within the master schedule.
Let me ask you a rather complicated question, right? And so what I've seen usually as a failure point within organizations, especially nowadays, is less so on the technical side, but more so on realizing the ROI from some of these deployments, right? Whether that's an ERP or ultimately, on the manufacturing side, the MES, they get the fancy software or tools that can pull the data. They understand they have maybe a batching system that can send, controls back to the tanks and, run whatever process or SKU that they need to. And ultimately the finished goods come out at the other end. Again, some get rejected. There's obviously some OE metrics, but maybe what are some, and I don't want to say low-hanging fruit because obviously that depends on the industry and a whole lot of factors, but maybe what are some of the use case that you'd say an MES truly helped us maybe uncover some of these problems and thus, make our operation either better or maybe make it on the financial side better or, less quality rejects. Could you paint us a picture of what someone could look at the MES and realize those gains?
Yeah, and it could be the MES, the ERP, it could be a number of different systems. But
Yes.
the basic idea, it's a fabulous question. The basic challenge is picture you're at a plant and you're on the leadership team, and once a quarter, everybody gets into a boardroom and they review how everything went and they look at these 20 KPIs or so. And then towards the end of this big rigorous review, the president says, all right, good job, team. Our mission is clear. We need to improve gross margin next quarter, and we need to minimize working capital. Great, let's go. And everybody in the room agrees. It's not. I'll say it's super rare that somebody's like, no, I don't want to do gross margin because I hate gross margin. I've always hated it. Usually, everybody in good faith agrees, and then the VP of Ops leaves, and the VP of Engineering leaves, and everybody goes out to try to make that happen. The number one difficulty, though, is before either of those folks even gets back to their desk, let alone starts to work on this problem, they're hounded with 7 different inbound requests for 7 other things that happened while they were in that meeting. And they never have time to sit down and really thoroughly go through all of the data. And more importantly, even if they had a staff member who could do that on their behalf, the data across these systems tends not to be integrated well. And so what you more commonly see is all of these metrics are effectively lagging indicators. So gross margin, I explained to you that I love gross margin. It's the greatest metric ever. You might be surprised to know that when I was running a company, I didn't know the gross margin for a month until a week after close. And so you would think, based on my commentary, that every morning I'm like, where's it at? What's our gross margin? What are we doing? Let's fix that. I wasn't. I didn't know until I was as surprised as the next guy once the quarter closed or the month closed. And I didn't even know where we were at until a week afterwards when they were able to reconcile all the financials. What I love about all of the digital technologies that are coming into play right now is that they basically let you get more granular in situations like that, and therefore empower the VPs of R&D, operations, supply chain, finance. Each of these folks can now have more specific data about what actual plant floor items drive those metrics and what doesn't. Whereas right now, you tend to be very crude. It's a standard, sledgehammer versus a scalpel situation. For the first time ever, we've now got composable MES systems, composable SCADA systems that can integrate to an ERP backend or an MES. And you can actually get metrics all the way down to the machine train level about availability, productivity, and you have much more specific data about what's actually driving those metrics. Whereas the reality is, if you were to just go to 100 random assembly plants in the United States, I'd be very surprised if they knew the utilization rate of every single piece of capital equipment or every single cell which has humans doing assembly work. It's very unlikely that today they know that, but the most important trend I'm seeing is that's being built up on composable MES and SCADA platforms. So just to give two examples, Tulip is a well-known one that's doing very well. It's a composable MES. Kanoa is another one that you can build on top of. And Ignition is a composable SCADA system. And the word composable simply means you can build a workflow on top of what is already there, which is really nice. So you can build workflows and KPIs in a way that you couldn't do easily, say, 5 or 10 years ago. This was a long way of me explaining that it's that granular data that really drives whether you're going to expand gross margin or not. But you don't really know until long after the fact, and you find yourself doing root causes in the old school methodology, trying to backfill a story about what is different from February to March, where gross margin tanked in March and we can't figure out why. Usually the answer lies in a richer layer of data about what played out on the plant floor that you don't have easy access to, that it would take a human forever to put together. Now, with composable platforms, you're able to kind of set that up in advance and break down, hey, we've only got 20 pieces of capital equipment. Those each have a certain capacity. Like, we can tell you exactly what deviated from the plan in a way that's very hard today, despite the best efforts of everybody involved. And that's what I'm most excited about.
Let me ask you.
Go ahead.
I'm sorry. Let me ask you a question, Glenn. And I guess before the question, I'll let everyone know, guys. I have a strong feeling we're going to blow over our 75-minute items here because I've got a question. I think Vlad's got a question, and then we want to talk about assets before we go wrap up with Glenn today. But Glenn,
Okay.
you were talking about gross margin. You were talking about it as a lagging indicator. Favorite preferred leading indicators on your side. What do you look for when we talk about KPIs and indicators? It's I'm sure a very easy question, right? There are just so many of them with so much information that we can all easily pull up very, very quickly.
Yeah, there are two that I really like, and they relate to quality and delivery. So for me, OTD usually behaves as a leading indicator. When you see your on-time delivery fluctuating all over the place or even trending downwards, it's usually signaling to you something unfavorable is happening in the system that wasn't there before, and you might not even be able to articulate what's going wrong yet. But in my experience, OTD tends to be a leading indicator that lets you know something's amiss. It's really worth staring at what's going different here, as do quality metrics. So in quality, I'll make a distinction here. On quality, you have two different ways of thinking about it. The most important, of course, is end user quality, which is always measured in DPPM, defective parts per million. This is the number of units that are sent back to your plant on the different names that they have. But the thing failed in the plant and it's coming back. Sometimes they're called NCRs before you ship them. But the item comes back, and that's kind of a field failure rate. The field failure rate in quality is a lagging indicator. The leading indicator happens at each of the individual work cells on the site. So if you're a site that takes the trouble to test all of the subassemblies as you're building any given product, and sometimes that's a system level test, sometimes it's a burn-in test, sometimes it's a script, whatever that test might be, deviations there are a leading indicator that something is amiss well before it'll ever show up in DPPM. And so if I had to pick two, I would say, broadly speaking, OTD is your friend. Like, it's really hard to fake OTD using the terms from earlier. It can be pencil whipped depending upon which fields you use, but let's assume we're all in good faith measuring OTD consistently. OTD, everything has to go right. Like, as soon as something starts going wrong, you're going to see it in OTD. And that's why I consider it a leading indicator. And I'm also just a huge fan of the double click layer of quality data or test data as you're manufacturing as a leading indicator way before the lagging indicator of the field failure rates, things coming back on from the field from the customer. Those are probably my two favorites. Yeah.
Absolutely. Vlad, do you have questions before we talk about enterprise asset management?
No, go ahead, Dave. I have many
Okay.
questions, but we will
Yes.
digress for a whole hour if I start
Yeah,
down
well,
that track.
I was going to say
Go ahead.
for all of our listeners who are still hanging out with us, this is going to be topic one of four or for 5 or 6 proposed topics that we had to talk about today. So I'm trying to get us through topic one so that we can bring Glenn back on at some point later and dive deeper into some more of them. So Glenn, can you finish out our what we should have probably just titled as ERP fundamentals for beginners, talking about EAM, enterprise asset management, please.
Absolutely, yeah. And thank you so much for giving me as much time as you have. I'll make this one super quick, even though it happens to be one near and dear to my heart. But here's the idea. So enterprise asset management is typically talking about not the process and the product that comes out the back door of your factory or process plant, but rather the machinery that you're using to do all of that. And so EAM, CMMS, or the maintenance work order module within your ERP, all of those are about maintaining the physical assets that help you produce, as contrasted with managing the raw materials and the production of the actual thing itself. So let's go through the 3-tier model. So the first thing is the master data. What is the master data for EAM? That master data is typically called the asset hierarchy. The most important data is all held within the asset hierarchy. It talks about the different systems, and they use the term functional location is what they tend to call it. So there's a system and a subsystem level, and these are all functional locations with a parent-child relationship. And eventually you get down to an individual asset record that is an identifiable asset. Like it's a centrifugal pump from Gould's. It's a back-end pull-out ANSI style pump. That's the asset record. And of course, that pump has nameplate ratings. It has very specific bearings inside of it. It has a shaft and an impeller that are repairable and replaceable if that were to go bad. And so all of that information is stored in this hierarchy of functional locations, asset records, and then they're called item records when you get down to individual procurable spare parts. So think bearing is an item. The pump itself is an asset. Everything that lets you know where that pump exists in the universe is a functional location hierarchy. That's the master data that we're dealing with. Then you get into transactions. Transactions are maintenance repair work orders. And in our world, we talk about 3 big kinds: corrective maintenance, a thing broke, bummer, let's go fix it. That's corrective maintenance. Preventive maintenance, it didn't break yet, but we're going to inspect it every 6 months just to make sure things are looking good. That's a PM or preventive maintenance work order. And then predictive maintenance, my personal favorite, we are predicting failures well in advance. The vibration spectrum shows an outer race bearing flaw. So we're going to swap that out on a piece of cake 2-hour work order in a orderly fashion, as contrasted with letting the thing fail. And now I've got to replace the entire pump because the shaft's all bent and it's a disaster. And that's my favorite. That's where we want to live, predictive maintenance work orders. For the purposes of this discussion about ERPs, the reason that EAM system exists, whether in the ERP or standalone, is to keep all of your capital equipment, your physical capital equipment that makes the stuff in good condition, repairable at the capacities that you want it to be at. And that's what the workflow is. At the end of the day, it's all about keeping that equipment up, healthy, and running at the quality that you expect. And that's the fastest I can do EAM, I think.
Absolutely. Vlad is going to pause to let me go get a couple of words in edgewise. Glenn, this was awesome. You've got a bunch of notes here. Is it okay if we go share these notes in the show notes?
Oh, yeah, heck yeah.
Perfect. So for all of our listeners at home, Glenn has done a fantastic job of outlining his mental model when it comes to ERPs with the master data, the transactions, and the workflows, and then also sub-modeling that out for financial accounting, supply chain, manufacturing execution system, and enterprise asset management, which is really fantastic. And honestly, Glenn, we'll let Vlad weigh in on it. I wish that someone had explained this to me just kind kind of mental models wise, the first time I had started looking at and working on ERPs. I feel like there have certainly been lots of homemade 50 to 300 page documents with lots of screenshots that I've seen of these are the 7 buttons we click to go from point A to point C in order to do the one thing that we need to do. And we'll see you in 7 to 45 days. The next time you need to do this again, hopefully you remember the keywords to get us back to this point in the manual. But overall, I think this is fantastic. Vlad, before we ask Glenn our wrap-up questions, did you have any other thoughts or comments on the model, on ERP fundamentals for beginners, any of those things?
I would say that, well, first, I guess a comment. Having been in a maintenance management position, I think I really appreciate your explanation and breakdown, Glenn, because I had to fight through understanding all of these details, so to speak, without any formal training at the time. And so the ERP systems that are, I want to say, unsophisticated, make it very difficult for someone to figure out what's truly going on and how to manage work orders while, simultaneously trying to assign them to a team that's executing the work orders. And I think there's newer solutions, some of which, we've seen at Prove It, and you'll probably see at other trade shows. And there's a lot of companies working in the CMMS space. So I'm definitely very excited as to how it's shaping up to be. But I wanted to ask you, maybe, what are you seeing as interesting opportunities ahead, specifically on the CMMS side, when it comes to different tools, technologies, maybe plugins, whether that's software, maybe hardware, or anything of that nature?
Yeah, so let me, I'll start by selling my own book, so to speak. I'm the chief product officer at Weights today, which is an awesome condition monitoring company. And I'm super excited about people that want to integrate their condition monitoring platform, of which my favorites is Weights Sensor Technologies, and integrating that into, thank you. Integrating that directly into CMMSs. And another time I'll dive into some really deep technical reasons why data can flow in one direction versus the other. But the gist is CMMS is a relational database. Your condition monitoring database is a source of really rich data types that have no logical home inside of the CMMS, but the CMMS cares deeply about the insights coming out of the condition monitoring platform. So step number one that I'm really excited about is people adopting a more modern wireless condition monitoring platform, and then having that integrate directly to the ERP, or in this case CMMS, to let them know you have a problem on pump 24, got to replace the bearing. Please schedule that within the next 8 weeks. Like, that's the system working exactly like it was intended. And so I'm super excited about that. And then moving to the future, we're now seeing some CMMS systems, the type that you would see at Prove It, like MaintainX, being really good ecosystem players inside of the Industry 4.0 stack. So like using MQTT messaging services and things like that to communicate with the other systems. And so for the first time, it's plausible to integrate your MES factory floor system with your CMMS, because both of those care a lot about whether a machine is up or down. From the MES side, you're scheduling production to try to meet all that challenging scheduling stuff that I talked about. From the CMMS side, you have this trade-off. You want to repair a thing as soon as possible. However, if you take it down right now, you'll interrupt production. So how long can you wait? This is genuinely the first time that I felt like you can meaningfully integrate a condition monitoring platform, a CMMS, and an MES, and have them all doing the thing that they were born to do in a really effective way.
Appreciate that.
Absolutely. I think that was fantastic. Thank you so much, Glenn. We will definitely bring you, or you and Dylan, back on it at some point to continue diving into a bunch of these topics. But we do want to ask you all of the questions that we get to ask all of our guests at the end. For any new listeners, the first one is always my favorite, right? The first one is putting the guest on the spot, although they know this before, and asking them to predict the future. So, Glenn, can you give us your predictions on ERP in the next 3 to 5 years? Please.
Absolutely. Yeah, in this prediction, I mean no disrespect to ERPs, because they do the hardest job in the universe, which is literally everything that exists at a plant. My prediction is it will be increasingly rare for a plant personnel to log into the ERP. Instead, they'll access the back-end ERP data through a series of systems, composable systems, that are layered on top of it. Those systems might be supply chain oriented, like a DDMRP system. They might be an MES system, a composable MES system that they've custom built for their own plant floor. But my baseline prediction is that it will be increasingly rare that you interact directly with your ERP at all. And it'll basically go down a layer in the stack to feel more like fundamental infrastructure that will never go away because it's critically important. But nobody interfaces with it. And instead, they interface with their favorite tool that's fit for purpose for what they're trying to do. And in the back, it's integrated to the ERP because at the end of the day, all of that data still needs to get to the ERP. It's a must-have system.
Interesting. I think that would make all of our lives so much easier, and I really do look forward to it and hope that that comes true. Unless you're the person integrating it, in which case you now have to take that financial model and build it to all of your composable solutions, which may or may not make your life easier.
Yeah.
But on the plant floor side, definitely very interesting. So Glenn, one of the things that we like to ask all of our guests is for some career advice. Typically, early to mid, if someone is early to middle career and coming to you and saying, "Hey, Glenn, what's the best piece of career advice you have for me, or the best piece of career advice you've ever gotten?" Can you tell us what that would be, please?
Yeah, so it's very similar to what I kind of opened with. I'll direct this at engineers like myself, especially if you're in the early stages of your career. You are going to overweight rationality in driving people's actions, and you are going to underweight emotion and different lenses through which the world can be seen. I would encourage you to do buff up all of your fundamental technical skills, including getting an MBA and learning financial accounting. I advocate for all of that, but you can still master the living heck out of absolutely everything on that side and be a deeply ineffective employee and team member if you don't start to master understanding the lens through which other humans are viewing situations and how they're motivated or demotivated by different things. And just always look for that. That will make you much more effective in getting things done in your career.
Any practical advice on how to do that?
That's probably another full podcast worth. Most people, to get very practical, most people will tell you, whether they mean to or not. If you start actually even looking for it without any formalized training, you'll say a thing to a person, they'll give you a facial expression, a body language posture. You don't have to be like an FBI interrogator to read the vast majority of this stuff. When someone's like, "Ooh, he didn't like what I just said there." Okay, fair enough. And then there's an art in these interactions to inhibit the part of you that you see that the person doesn't like what you just said. And then you double down, I'm going to tell you even more firmly with more data why I'm right. That is the exact wrong instinct. What you want to do, okay, awesome, here's a learning opportunity. I just hit a nerve. I have a chance to learn a different lens on the world. And rather than completely alienate this person, let me breathe, make the safe space. Let me talk to this person, understand how they're thinking about things. And if you can do that, you'll know it when you're in that space. You'll know it if you're just paying attention to intonation, body language, and facial expressions, and then make that person feel safe to tell you what's really behind the scenes and why they're reacting the way they are. If you do that, you're on the right path.
Appreciate that.
Absolutely. I think that's really good advice. Vlad has probably heard me describe when I talk about motivations, I like to talk about dogs, right? So we own dogs, and you will know that some dogs are very food motivated, right? And so that is a key motivator for some dogs. Our current puppy Archie at the moment, absolutely not food motivated whatsoever. He'll leave the food there, but if you figure out the thing that he wants, to very much to your point, Glenn, absolutely super happy to go do that thing that you want him to do because you asked the correct question. And I think to a large extent, it's just going through the process of quantifying what could motivate people, right? Is it praise? Is it money? Are they looking for more money? Are they looking for more visibility? And then how do they go about the process of making those decisions? And at the end of the day, sometimes you'll learn that people are very happy doing exactly what they're doing, exactly how they're doing it. And so it's how do we just not rock the boat, and how do we allow them to go continue to live their life exactly the same way or as close to the exact same way, because there's nothing that one could give them that's going to motivate motivate them to do the thing that you want them to do while they're working. So I think that is fantastic. But I would agree that that's probably like multiple hours of conversations, and we could
Yeah.
probably put together a really nice table, Vlad. Maybe pull out the Miro board at some point. Absolutely. So, Glenn, this has been fantastic. We always like to ask our guests for book or content recommendation, and I see you've
Nice.
got at least a book recommendation, and some other
Yeah.
stuff in here. So what do you have for us today, please?
Yeah. So aside from very well-known things like the Feynman lectures in physics, which are outstanding, but the entire world knows about them and knows to go check them out because they're good. My favorite technical writing is written by a gentleman named Tony Kuphalt. It's a strange last name, but Kuphaldt. He's written a monstrous tome. It's thousands of pages, and it's called Lessons in Industrial Instrumentation. Believe it or not, I've read it. I've read it cover to cover because I absolutely love it, and it's free. It's online. So
Okay.
if you simply Google Tony Kuphalt Lessons in Industrial Instrumentation, you can buy it on Amazon if you so choose, but know that he posts it free for the world to see. It's just a class act in technical writing. It's some of the best technical writing I've ever encountered, and I would love for more people to read that. And a shout out to Tony, he's done the process industry a really big service by writing that book and making it freely available to all.
That is awesome.
Absolutely. No,
I'll definitely
that's
have to check it
awesome.
out. Mhm.
Yeah, he has another one that I haven't read, Vlad. That's all about electronics, and I can only read so many 2,000-page books. But he's got another 2,000-page one on electronics, and you
Man,
might want to.
that is impressive. It
Yeah,
is really hard to get anyone to go sit through 2,000 pages, much less 2,000 technical pages, if it's
yeah,
not a manual and if you're not physically forced to go sit in a windowless room and read that. Not that some of us have done that multiple times in one's career. But no, that's awesome. Thank you so much for that, Glenn. If you guys are watching online or listening at home, we've dropped those the lessons in technical instrumentation by Tony Kuphalt, whose last name I'm almost certainly mispronouncing. In all of the chats, if you guys are listening on podcast form, it will definitely be in the show notes. Last question that we ask all of our last question that we ask all of our guests, Glenn, is how can our listeners help? Who should reach out? Who are you guys looking to connect with? Kind of your open platform to ask the listeners who have gotten so much in the last almost 90 minutes, how they can help you.
Fantastic. Well, I'll just be very brief, but right now I'm with a fabulous condition monitoring company named Weights, Waites. If you're considering condition monitoring, there's a million reasons to choose Weights, and I'm a huge fan of vibration analysis and predictive maintenance. So if you want to geek out, and even better, if you'd like me to have you set up with one of our salespeople, please come talk to me about Weights. And that's just simply www.weights.net to check out Weights. And I'm also in the process of launching a new business with Dylan Dufresne, as we discussed earlier. Dylan is a super impressive guy with a systems integration and Industry 4.0 stack background, but he knows a lot beyond that. He's conversant in many of the topics that we talked about today. And so I'm super excited to launch that business. It's called Abelara, and the website is Abelara, ABARA.com. We have a variety of coaching, consulting, and integration services. And really what you're buying is me and Dylan. We just love this stuff. There's a lot of services that we can offer. And if you like to geek out like we do on ERP or any technical topics, reach out and would love to talk to you.
Awesome.
Awesome.
Glenn, this has been absolutely fantastic. As I told the listeners, I think we're probably like 1/10 of the way through all of the things that we could have talked about. So look forward to having you back on at some point. Look forward to having you and or Dylan back on at some point for a larger roundtable conversation on a bunch of these other things. I think that would absolutely be a lot of fun, and I'm sure our listeners at home would as well. But for the listeners at home, thank you guys for hanging out with us. It's always so much fun. As I say, it's the best 90 minutes of my week, and this is definitely the best 90 minutes of my week. We had Tim in the comments saying that the best podcast that he's attended over the past year. So Tim, if you are still listening, thank you so much for that. Again, Glenn, absolutely instant classic. on Manufacturing Hub. So if you guys are watching on LinkedIn, make sure that you're connected with Glenn. Make sure that you are following Abel Lara, whose name I will probably now mispronounce for the rest of our lives, but this is 100% on Dylan. Make sure you're following Vlad and myself in Manufacturing Hub. Go check out Talon, TALAN.com. Thank you guys once again for sponsoring this entire ERP theme. If you made it this far on YouTube or podcast format, please give us a thumbs up, give us a like, hit the subscribe button, rate us 5 stars, and follow along in all your podcast platforms. When I ask, you guys follow along, and then Vlad launches the podcasts, and then you guys listen to them, which is a pretty amazing 1, 2, 3 sort of effect. Again, everyone, thank you so much. Until next week, we'll see everyone.